Hi, I'm Farhana and welcome back to the fourth lesson on trigonometry rules. In this lesson, we'll consolidate what we learned in the last three lessons on all three rules. Let's begin. So, I'm sure you've always wondered how you'd know which rule to use in any given triangle. That's the question we're going to answer today. Let's quickly look at our concept map though. So remember again, we were dealing with solving non-right angle triangles, and so far we've done the sine rule, the cosine rule and the area rule. Let's quickly recap what all three rules are. I hope you remember all three rules. They were pretty simple to memorize. We did do some tricks to try and make it easier to memorize them. So let's see how much you can remember. Okay, so first we're going to do sine rule, and remember the sine rule for any triangle ABC. There's two versions. The version with the angle on top, sine A over A equals to sine B over B, which equals to sine C over C. And this version is the version we use when we're trying to find angles. The second one we have is the version with the sides on top. It's just a reciprocal of the previous one. So A over sine A equals to B over sine B, which equals to C over sine C. Now, can you remember when do we use the sine rule? What's the criteria for that? Let's check. Okay, we need to have one full pair and one half pair. So we need one pair of angles and sides. We need to be given one pair, and we need one half pair. So either we can be given that and then we can find the angle, or the other way around. Okay, and remember in sine rule there is the ambiguous case. Can you remember when the ambiguous case is applied? Remember sine rule you need one full pair of angles and sides and one half pair. But the ambiguous case is a specific case of the sine rule. This occurs when we have two sides and an angle given, but specifically remember the full pair that we're given contains the smaller of the two sides. So the full pair that we're given contains the smaller of the two sides. 6 is smaller than 10, and so we will have the ambiguous case. Remember, when we have the ambiguous case, it means we can draw two different triangles with the same information. Okay, and the next rule that we got to remember we did is the area rule. The area rule was pretty simple. We used the area rule to find the area of a non-right angle triangle. Can you remember? This was pretty easy to remember. Half, if you had an AB and then you put a C there. So it was half AB sine C. Second version, half BC sine A. And I'm sure you can recall the third version. It's half AC sine B. Now, can you remember what you need to use the area rule, what you need to be given? That's right, you need side, an included angle and a side. So for area rule, you need to be given side, angle side, and it needs to be an included angle. Okay, and the last rule we did was cosine rule. So you could use cosine rule when you had two sides and an included angle, and then you'd use the standard versions of the cosine rule. And let's remind ourselves for triangle ABC, it was a squared equals b squared plus c squared minus 2bc cos A. B squared equals a squared plus c squared minus 2ac cos B. And the third version, c squared equals a squared plus b squared minus 2ab cos C. So there was another situation when we used the cos rule. Can you remember what that was? Correct, when we were given three sides. So when we have three sides, then we can use one of these versions of the cos rule. So if we want to find cos A, then we'd use, if we want to find angle A, then we'd use this version of the cos rule. So basically we just use the original versions and we just manipulate it a little bit until we have cos A, the subject of the formula. And then remember, we'll use shift cos to find the actual angle on our calculator. And similarly, if you were looking for angle B, then this is the formula that you're going to be using. And if you're looking for angle C, then this is the formula you're using. You don't need to know these formulas off by heart. You can use the original formulas and just manipulate them to get to this version. Okay, now let's see if you can understand how to put all three rules together and decide which is the most appropriate to use in any given situation. Let's summarize this quickly. So, which rule to use? Pretty simple. Okay, first we're going to ask ourselves, is the triangle right angled? If it is, then we have to ask, does the question involve angles? So if it involves angles, simple. Now we're just going to use grade 10 work. And what was the grade 10 work? It was the introduction to trigonometry where we did the trig ratios. So we've got to use the SOHCAHTOA, sine equals to opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Okay, what happens if the question doesn't involve angles? Then you've got to use the theorem of Pythagoras. Okay, then we're using the theorem of Pythagoras to find the sides. What happens if the triangle is now not right angled? What happens in that case? Okay, then we've got to see if we have one full pair, that means we've got an angle and its matching side. If we have the angle and its matching side, then what rule is that? Of course, it has to be sine rule. So if we don't have one full pair, what's the other option to use? We have to use cos rule. So let's look at this again. If the triangle is right angled, if it involved angles, then you're going to use our grade 10 work. If it involves only sides, then you're going to use theorem of Pythagoras. If the triangle is right angle, not right angled, and then if you have one full pair, then you can use the sine rule. And if you don't have a full pair, then you're going to use the cosine rule. Okay, it seems a little bit complicated maybe perhaps right now, but it'll be very easy as soon as we look at some actual triangles and decide which rule to use. So let's go and do that. Okay, in this first triangle, let's first answer, is it right angled? No, there is no right angle in this, so there is no right angle in here. Okay, do we have one full pair of angles inside? Yes, we have one full pair of angles inside. So which rule will we use here? Easy, we're going to be using the sine rule. And if we're using the sine rule here, what will we be finding? We'll use this as our half pair and we'll be finding this angle. Okay, let's go to this next triangle here. Start asking our questions again. Is it right angled? Yes, it is a right angled triangle. So because it's a right angled triangle, we're going to ask our question, does it deal with angles? Yes, it's dealing with angles. So because we're dealing with angles, it means we've got to use our trig ratios. So we've got to use one of our trig ratios here. And if you look at this specifically, depending on what you wanted to find, because you wanted to find the adjacent angle and you're given the hypotenuse, you're going to be using cos of 25 is equal to A over H to begin solving that triangle. Okay, we've got a few more to practice on. Let's look at this. This one here, is it a right angled? No, it's not a right angled triangle. Does it have any full pair of side and matching angle? So we've got no full pair as well. So what does it mean we have to use? We've got to use cos rule. And cos rule, why? Because we have side, side and side. And we use cos rule, we can find any of the angles. Look at this triangle again. Again, it's a right angle triangle. And yes, it involves angles. So again, we're going to use one of our trig ratios. Specifically, which trig ratio will we be using? We'll be using the one that says opposite over hypotenuse. So we'll be using our sine is equal to opposite over hypotenuse. Okay, the next one again, here we've got what? Do we have a not right angle, is it a right angle triangle? No, it's not right angle triangle. Do we have a full pair? No, we don't have any full pair, if you look at it correct. All we have is a side, an angle, and a side. So we have that V pattern. So we're definitely going to be using cos rule here. Okay, I hope this is getting a little bit easier. Let's try. I think we've got two more left to do. This one here again, it's a right angle triangle. And if you notice carefully, there is no angles given. So because there is no angles given and we want to find sides, we're going to use Pythagoras to solve this triangle. Okay. This one here, we have one full pair of sides, so it's going to be sine rule. Okay, I hope this is getting a bit easier for you. This one here again, it's a right angle triangle and it's involving angles. So again, you're going to use your trig ratios from grade 10. Okay, so I hope you have some idea of how to decide which rule to apply when looking at a specific triangle. After the break, we'll continue with looking at some specific examples in solving the triangles.